Grade 9 learners, are you ready to have some fun in science again? If you're ready, so am I. So let's get it on! I am Teacher Jane from Zamboanga del Norte National High School, and I will be your companion for today's lesson. So just sit back, relax, and enjoy this sci venture. This is Science R with Teacher Jane. Last episode, you have learned about the different factors that affect climate, which are the latitude, altitude, and topography. Let's do a quick recap about the last lesson. Climate is the weather conditions prevailing in an area over a long period. There are different factors that affect climate. First is the latitude. The latitude is the most significant factor for determining climate. The equator receives direct rays of sunlight, which means the sun delivers more heat than slanted rays. Therefore, it is warmer at the equator. The farther allocation from the equator, the less heat it receives because of the slanted rays of sunlight. So, it is colder at the poles. Second is the altitude. Altitude means the height above sea level. The air temperature decreases as the altitude increases. This simply means as you go up in altitude, you go down in temperature and sometimes precipitation. This explains why do mountain climbers wear thick jackets and thick clothes when they go up the mountain. Third is the topography. The lay of the ground plays an important role in regulating climate. One of the topographic features of an area is a mountain. Moist wind coming from the sea flow up the mountain, but because temperature falls with altitude, water vapor eventually condenses and there is precipitation. This side of the mountain is what we call the windward side. The other side of the mountain is what we call the leeward side, which is dry and has less precipitation. You have now identified some factors that affect climate. The next activity will help you deepen your understanding about climate. The objective for this lesson is for you to explain how distance from bodies of water and ocean current affect the climate of an area. Sounds exciting, right? But before we start, I want to ask this question first. Which do you think will heat faster? Is it the soil or the water? Let's try to find out if your prediction is right. So here's a short video of my experimentation in determining which heats faster and cools faster between the water and the soil. These are the materials that we need in this experiment. A pair of identical containers. You can use any containers at home as long as it is identical. Fill in 1 cup of soil and water for each container. 2 thermometers. You can use digital thermometers at home. An iron stand and iron clamp. You can use any materials at home that can hold the thermometer during the experiment. So prepare the setup like this. Make sure that the tip of the thermometer in the water should not touch the bottom of the container. And now, let's take the initial temperature of the water and the soil. As you can see, the initial temperature of the water is 30 degrees Celsius, and for the soil is also 30 degrees Celsius. Record it in a table. Take note of the initial temperature of water and soil. Bring it under the sun and record its temperature every 5 minutes for 15 minutes. After 5 minutes, the temperature of the water is 36 degrees Celsius and the soil is 37 degrees Celsius. After 10 minutes, the temperature of the water is now 37 degrees Celsius while the soil is 39 degrees Celsius. After 15 minutes, the temperature of the water is now 38 degrees Celsius, while the temperature of the soil is now 42 degrees Celsius. These are the data of temperature readings under the sun. Now bring it back to the shade and record its initial temperature. Record again the temperature every 5 minutes for 15 minutes. After 5 minutes of waiting, the temperature of water is now 36 degrees Celsius and the soil is 38 degrees Celsius. After 10 minutes, the temperature of water is 35 degrees Celsius while the soil is 36 degrees Celsius. And after 15 minutes, the temperature of water is now 34 degrees Celsius while the soil is 35 degrees Celsius. This is now the data of the temperature readings under the shade. So let's take a look at our data. What are the initial temperature of soil and water? The water and the soil both have the same initial temperature of 30 degrees Celsius. What is the difference between the temperature of soil and water after 15 minutes? The difference of the temperature of the soil from 30 to 42 degrees Celsius is 12 degrees Celsius, while the temperature of the water from 30 to 38 degrees Celsius is 8 degrees Celsius. Which has a higher temperature after 15 minutes when exposed to the sun? Is it the water or the soil? Based from a record, the answer is the soil. So which heats up faster, water or soil? As shown in our data, it is the soil that heats up faster. Now, what happened to the temperature of the water and the soil when brought to the shade? Bringing them into the shade makes its temperature decreases. So which cools faster, water or soil? The data shows that the initial temperature of the water when brought to the shade is 38 degrees Celsius and went down to 34 degrees Celsius after 15 minutes. So the difference is only 4 degrees Celsius. While the soil is from 42 degrees Celsius, it went down to 35 degrees Celsius, which has a difference of 7 degrees Celsius. This means that the soil cools faster than the water. There you have it. So, is your prediction right? Great! You just figured out that the soil heats and cools faster than the water. But what it has got to do with climate? The climate of an area can be affected by the surrounding bodies of water. The last activity shows that soil absorbs heat faster than water. At the same time, soil releases heat faster as compared to water. It is because water is a slow conductor of heat. Thus, it needs to gain more energy than the sand or dry land in order for its temperature to increase. Places that are near the oceans have a moderate climate as the body of water regulates the temperature. Because soil heats up faster than water, the air temperature above the sea is lower than above the ground during daytime. Warm air thus moves out from land to sea, slowing the rise of air temperature above the land. Thus, places without body of water nearby tend to have higher temperature during daytime. At night, soil cools down faster than water, so the air temperature above the ground is lower than above the sea. Warm air then flows from sea to land, so the drop in air temperature above the ground is moderated. Places that are far from bodies of water have extreme climates, as there are no immediate bodies of water that will help circulate the movement of cold and warm air. Water absorbs more heat during summer. This is why, during summer, areas near a body of water stay cooler with moderate temperatures. In winter, the surrounding water slowly releases heat, causing the cooling effect to become lesser than normal in the nearby landmass. Just to make it clear, places that are far from bodies of water have extreme climate because there are no bodies of water that will moderate the change in temperature. Got it? Brilliant! Now let's move on to the last factor affecting climate, which is the ocean currents. Currents are flows of gas, water, or air, and that heat from the sun creates convection currents that cause wind to blow. The wind that blows over the ocean water creates waves. It also creates surface currents, which are horizontal streams of water that can flow for thousands of kilometers and can reach depths of hundreds of meters. So here's another activity for you folks. For this activity, we will be using the map with ocean currents of the world. Using the map shown on screen, help me find out what current is being described. The red arrow represents warm ocean current, and the blue arrow represents cold ocean current. So get ready with your pen and paper to help me out. All set? All ready? Warm ocean current originating in Gulf of Mexico along the east coast of the United States. Again, warm ocean current originating in Gulf of Mexico along the east coast of the United States. Have you found it? There you are. It is the Gulf Stream. Next is a cold ocean current flowing from the Arctic Ocean south along the east coast of Canada. Again, cold ocean current flowing from the Arctic Ocean south along the east coast of Canada. Found it already? If your answer is Labrador Current, you're absolutely correct. Next, east to west flowing current from 10° north to 20° north in the Pacific and Atlantic Ocean. Again, east to west flowing current from 10° north to 20° north in the Pacific Ocean and Atlantic Ocean. Just follow the latitude given, and there you have it. It's the North Equatorial Current. Right! Next, north flowing warm current off the coast of Japan in the Pacific Ocean. Again, north flowing warm current off the coast of Japan in the Pacific Ocean. Very easy, right? Japan is here near the Philippines, and you can see immediately the Kuroshu Current. Next is the southward flowing current of the west coast of the United States in the Pacific Ocean. Again, southward flowing current of the west coast of the United States in the Pacific Ocean. So we are looking for a southward movement of the current in the western part of the United States. And there, it is the California Current. All right, thanks for helping me out in determining those currents. I hope you're having fun locating it as much as I do. So what has it got to do with climate? Well, surface currents are an important factor in the ocean because they are a major factor in determining climate around the globe. Because the Earth's equator is warmed by the most direct rays of the sun, air at the equator is hotter than air further north or south. This hotter air rises up at the equator, and as colder air moves in to take its place, wind begins to blow and push the ocean into waves and currents. From the equator, warm water pushes outward to the north and south poles at the same time. Cold water from the north and south poles collide with this warm water. Because Earth spins on its axis, water flows in a circular pattern. This causes currents to flow clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. These clockwise and counterclockwise movements of ocean currents are caused by the Coriolis effect. So you see, the air above the warm water has a higher temperature. When warm ocean currents that take along warm water go to a landmass, the temperature of that place increases as warmer air above the water flow inland, resulting in a warmer climate. In a similar manner, cold ocean currents that bring cold water as they move towards coastal region cause the temperature of that area to decrease as warmer air from that land flows to the sea, resulting in a cold climate. Were you able to get it now? Great! So deep, huh? Deep like the ocean. I guess you're ready for a short game to check your understanding of this lesson. Get your pen and paper ready. I'll give you 5 minutes to answer, and the time starts now. Time is up! Let's see if you've got the correct answer. Complete each statement by choosing the correct word in the given pair. The soil heats up faster than water, so air temperature above the sea is lower than above the ground. Places that are far from bodies of water have extreme climates. The water temperature rises or falls more slowly than soil because water has higher heat capacity. Places without a body of water nearby tend to have higher temperatures during daytime. At night, soil cools down faster than water, so the air temperature above ground is lower than that above the sea. Gulf Stream carries warm water from the east coast of the United States to the west coast of Europe. The current flows counterclockwise in the southern hemisphere. When ocean currents that bring cold water move towards a coastal region, the temperature of that area decreases as warmer air from the land flows to the sea, resulting in a cold climate. Warm ocean currents generally come from the equator. Water flows in a circular pattern because of the Earth's rotation. Well, I hope you got a perfect score, or at least a passing one. Did you? Genius! Alright then, that is all for today's session. But I'd like to leave this to you as your additional task at home. Easy to say, essay. If you were to choose a place to live in, where will it be and why? Explain your answers using the factors affecting the climate of a place. You can answer it on a sheet of paper. So I guess this is it, another achievement for our SciVenture buddies. I hope you have learned something in this session, and we'll see you again in our next episode of SciVenture. This is your teacher Jane, and this is Smile TV.